Alright guys, so before we start the new stuff in the next module, we need to review a little bit from some Algebra 1 and pre-algebra stuff that you guys learned. So some stuff we need to review is radicals, okay? So we're up here in the directions. Remember your perfect squares, okay? All these numbers right here are called perfect squares because you can square a number to get them. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and so on and so on and so on, until you get up to 144, which is 12 squared, and they keep going forever and ever and ever. But those are the ones you'll use most of the times because they're smaller. So if you can remember these, it'll make these problems a lot easier. So number 1, the square root of 36. Okay, so 36 is a perfect square. Whenever it's a perfect square, you're taking the square root of. It's really easy, okay, because the square root is just asking, what do you multiply by itself to give you that number? So what I multiply by itself to give me 36? It's simple, 6, okay? So those are pretty simple, but whenever you've got one like number 2, where it's not a perfect square, okay, notice up in our list up here, 24 is not one of those numbers, okay, it's a little bit tougher. So what you want to think is which one of these perfect square numbers that I have up here listed, which is the biggest one that will divide evenly into 24, okay? And a good place to start is a number that's about half of 24. So half of 24 is 12. So I'm going to look at the ones right here that are about half of 24 or less. So 16. Will 16 go into 24? No. What about 9? 9 go into 24? No. What about 4? Yes, 4 goes into 24. Okay, so I'm going to break this down into the two numbers that multiply. 4 times 6. All right. So then I'm going to put the square root over 4 and square root over 6. The square root of 4 times the square root of 6 will give me 24, or the square root of 24. Okay, so now once I break it down like that, now it's simple because 4 is a perfect square, so I can do the square root of 4 and make it 2. And then square root of 6, I can't break it down, so it's just 2 times the square root of 6. All right, so that's how you do ones that don't just have a perfect square number underneath. Okay, so that answer is 2 square root of 6. Number 1 is just 6. I'm going to pause the video, let you guys try number 3 and 4. This first one, you're going to look at the square root of 45. Now, don't be confused by the number out front. You're going to use it later. Just bring it down and leave it out front until we get to the end. So 45, what's the biggest perfect square out of all those numbers up top that will go into 45? So we'd look at about half of 45, which is around 24, 25, somewhere around there. Does 25 go into 45? No. The next one, 16. Does 16 go into 45? No. What about 9? Does 9 go into 45? Yes. 9 times 5 is 45. So we break it down into 9 and 5. Square root of 9 times square root of 5. Square root of 9 is 3. And to bring down the square root of 5. Now we use the 10 because the 10 was outside the whole time. So now we got 10 times 3 on the outside, which gives us 30. So it's 30 square root of 5. All right, let's settle number 4. We got square root of 100. Oh, well, 100 is a perfect square. That's easy. Square root of 100 is 10. So we've really got 4 times 10, which is 40. All right. So that's how you simplify radicals. Okay. Now let's look at simplifying some that are written as fractions. Okay. Now, whenever you've got radicals in fractions, the thing you've got to be aware of is that you're not allowed to leave a radical on the bottom of a fraction. Okay, it's not simplified if there's a radical on the bottom of a fraction or a square root. When we say radical, we mean a square root, same thing. Okay, so I can't leave the square root symbol on the bottom. So this first problem here, it's easy to get rid of it because I've got the square root of 9, and 9 is a perfect square. So this is really the square root of 10 over the square root of 9 equals 3. Okay, so that one's easy. The square root's not on the bottom anymore. The only thing I'll need to make sure is that I can't simplify the square root of 10 by the same way I did the problem from before. So 10, number that will go into 10, well, 5, a perfect square is 4. 4 won't go into 10, 9 won't go into 10. So there's no way to simplify that anymore because nothing can simplify the square root up top. So that's just square root of 10 over 3. Okay, so number 6. Now the bottom square root, 32, that's not a perfect square. All right, so what you've got to do in this situation is we're going to multiply by that square root. Okay, and here's the reason why we do that. If I do the square root of 4 times the square root of 4. All right, well, let's not use 4. Let me use 3. Something that's not a perfect square. Square root of 3 times square root of 3. Well, that's going to be the square root of 9, which is a perfect square. That's 3. If I did the square root of 7 times the square root of 7, well, that's the square root of 49. Square root of 49 is 7. Okay, so that's why we do that, because that helps us get rid of the radical. There's no radical on these anymore. So that's what we're going to do on these problems. But here's the thing, you can't change the value of it. So if I multiply the bottom by the square root of 32, I've got to multiply the top by the square root of 32 also. So then up top, I've got 2 times 32, which is 64. On the bottom, I've got square root of 32 times square root of 32, which just gets rid of the radical. So the radical goes away, and I just have 32 on the bottom. So now we got to simplify the top part, square root of 64. Oh, well, that's one of our perfect squares. Square root of 64 is 8. So I have 8 over 32, and that reduces to 1 over 4, because 8 divides by 8, and 32 divides by 8. So when I divide those, I get 1/4. Alright, so again, that's a little confusing. Whenever you're radical on the bottom, it's not a perfect square, just multiply the top and bottom by whatever that radical is, and then simplify from there. Okay, of course on the bottom, square root of 32 times square root of 32 is just 32, and up top, you got to simplify it just like we did the first 4 problems. And if you get a fraction, reduce. Okay, so I'm going to pause it, let you guys try number 7 and number 8. Number 7 is pretty simple because the bottom square root has a 25 in it, which is a perfect square. Square root of 25 is 5, and the square root of 10 on top can't simplify. Now, a lot of people right here would want to do 10 divided by 5 and get 2, or say it's the square root of 2. You cannot do that because the 5 is not in a square root, the 10 is, okay? So think of the square root like a jail. You don't want to go inside jail if you're out of jail. So the 5, he's outside jail. He's not going to go in jail and divide the 10. He's not going to do that. He's going to stay outside of jail. So that's done. Square root of 10 over 5 is the answer. Okay, this next one, the radical on the bottom is not a perfect square. So you have to multiply by the square root of 45 on top and bottom. On bottom, of course, the square roots just go away and it leaves 45. Up top, 5 times 45 is 225. Okay, so then you've got to figure out with 225 what is a perfect square that will go into 225. Okay, well 25 will go into 225. So I say, all right, we'll do 25. And then I'll divide 225 in my calculator by 25. And whenever I do that, I get 9. So I say, oh, that's square root of 25 times the square root of 9. Well, both of those are perfect squares. That's cool. So square root of 25 is 5 and square root of 9 is 3. So it's just 5 times 3, which is 15. So actually, 225 was a perfect square. We just might not have known that because it's such a big number. But if you break it down just like you're supposed to, you'll still get the right answer. So that's not a big deal if you get a big radical. If you break it down the right way, it shouldn't matter. So up top, we have square root of 225 is really 15 over 45. Well, those both divide evenly by 15. 15 divided by 15 is 1. 45 divided by 15 is 3. So the answer is 1/3. All right, let's look at a couple of others that might have some extra numbers on there instead of just the radicals. So these actually have numbers out front of the radicals. And the only thing that's different is you're going to multiply those by whatever comes out of the radical. Okay, so for number 9, the radical on the bottom, oh, it's a perfect square. Awesome. So we got 4 square root of 12 over 4 times the square root of 9 is 3. So it's 4 times 3, which is 12. Now again, the number on the bottom cannot go inside the radical, but it can divide the number that's up top that's outside of the radical. So 4 over 12, you just treat this like you would a fraction, like you would any fraction. 4 over 12 reduces to 1 over 3. So you got 1 square root of 12 over 3. Okay, and right here, one that's cool is the 1 is not really necessary because it's 1 times something, so that's just that one thing. Okay, so now let's see if we can reduce the 12. So 12, square root of 12, does it have a number that would go into it that's a perfect square? Well, half of 12 is 6, so check any of the perfect squares, 6 and below. 6 isn't a perfect square, and neither is 5, but 4 is. But yeah, 4 goes into 12, so we break it down to 4 times 3. Square root of 4 is 2. Can't do the square root of 3, so it's 2 square root of 3. So I really have 2 square root of 3 over 3. Now, will the 2 over 3 reduce? No, 2 over 3 doesn't reduce. So this is as simple as it gets. And again, you can't divide the 3 on top by the 3 on bottom because the 1 on top is in a square root, 1 on bottom is not. All right, so let's look at number 10. This time, the radical on the bottom is not a perfect square. So we need to multiply by square root of 20 on top and bottom. Now up top, I have 4 square root. 15 times 20 gives you 300. Then on bottom, I have 4. And then square root of 20 and square root of 20 is just 20. So on the bottom, that's really 80. Up top, I have 4 square root of 300. So now we've got to break it down 300 and figure out what's the biggest perfect square that will go into 300. Well, 100 does. 100 times 3, right? So square root of 100 times square root of 3. Square root of 100 is 10. And square root of 3 doesn't simplify, so you got 10 square root of 3. So now up top, I have really 4 times 10 square root of 3 over 80. 4 times 10 is 40 square root of 3 over 80. Then you can reduce the numbers on the outside. 40 over 80 is going to be 1 over 2 because they both divide evenly by 40. 40 goes into 40 once, 40 goes into 80 twice. So it's really 1 square root of 3 over 2. All right. So again, the only difference on these is there's a number out front of the radical. You just multiply it by whatever comes out of the radical whenever stuff simplifies. So go ahead and try 11 and 12 and we'll be done. Okay, so number 11, the bottom radical has a perfect square. Square root of 36 is 6. So you do 5 times 6 and get 30. And then we've got to simplify the square root of 8 up top, so it breaks down into 4 and 2. Square root of 4 is 2, so you have 2 times the square root of 2. So then you replace, okay, we're going to replace right here, since square root of 8 is this, we're going to replace this square root of 8 right here. But there's still 2 out front. So you multiply the 2 that was out front originally with the 2 that we found out front now, and that gives us 4, right? So these 2 right here give us the 4. And then we've got 4 square root of 2. Then 4 over 30 reduces because both of those will divide by 2. So we divide them by 2 and we get 2 square root of 2 over 15. Number 12. The radical on the bottom does not have a perfect square, so we multiply by that radical on top and bottom. Square root of 50 on top, square root of 50 on bottom. Up top we get 5 square root of 100, and on the bottom we get 3 times 50, because square root of 50 and square root of 50 gives us 50. Then up top we see, okay, well square root of 100, that's a perfect square, awesome. So that's going to be 5 times 10. So 5 times 10 is 50, 3 times 50 is 150. So we get 50 over 150, and that reduces to 1/3 because both of those will divide by 50. All right, so answer on that one's 1/3. Okay, appreciate y'all paying attention. Time to practice.